So as I was saying, I'm Elsie Marion. I'm a DevSecOps engineer. This call is now being recorded. Sorry about that. And I'll be your moderator for tonight. Thank you so much for joining in. And it will be nice during the session if you're more interactive. Okay, I'm now back to sharing my screen and we can start off. Just a minute. Okay. Let me know once you're able to see my screen. At least thumbs up or something or a comment. Nice. Thank you. So first of all, we have our quote for the day and it is Siri ni kujituma. So by Siri ni kujituma, it basically means showing up and then giving your best in whatever you do. Maybe things are not working out or maybe things are working out. So the best thing you can do is be disciplined. You show up, ujitume, and then it will all work out. Now, let's start off. For today's agenda, we'll have an icebreaker, and then there's the meeting expectation, a little bit about the Nairobi DevOps community, and then we'll have a session on Dockerizing Django app. And lastly, we'll have a Q&A. Now, for the icebreaker, I do have I don't know if it's a question or it's a funny joke. Anyway, here we go. So my question is, why did the programmer leave the camping camp early? Who can try? Anyway, now by the way, niko na zawadi for the first person to get it right. Anyone? Any trial? Sijui ka ni joke ama ni question. You can type it in the chat. Hey, nyi watu najiongelesha, hata kuna mtu anajaribu. Hamtaki kujaribu? Anyway, mtu atajibu tu, kutakuwa na. Okay, we have the first answer. Oitaka. I hope I'm pronouncing that right. Amesema because there might be too many bugs. Any other trials? Any other? Wamesema the loop terminated. Okay. By the way, niko na zawadi on a serious note. Anyway, since we just have two responses, I think the right answer is because there were too many bugs. Bugs ya code, see bugs ya insects. So congratulations, Waitaka. Unione nyuma ya tent afterwards. Thank you for being active. Okay, now for the in-house rules. First of all, it will be nice if you muted yourself and then you raise your hand if you want to speak. Also, you can use the chat box to write your comments and questions. Lastly, kindly also be respectful to one another and be curious. Tumekuja kusoma and tumesema tuna show up. So, uulize maswali kama uelewi. And now a little bit about the Nairobi DevOps community. We have our mission. So the goal is to create a supportive and inclusive community where everyone is able to learn and grow, not only career-wise, but as a person, yeah? And then we also have a vision, is to be innovative and empower professionals, not only in, because it's Nairobi DevOps, not only in Nairobi, but all over. And then we have our team. So this is the team that makes everything possible behind the scenes team. Tuko wengi, I can't mention all of them, but yeah, we appreciate them for their effort. In case you would like to volunteer or help us out in a way, you can always help by talking. You can always present your talks. Kwanza ndo tumeanza mwaka. It will be nice if you're willing to talk on something. You can also connect us with professionals in this area by giving feedback. This is very important. It could be a positive, like something good, or positive criticism, something that we need to improve on. Also, you can share your ideas. And by sharing our post, could be on LinkedIn, on WhatsApp, wherever. Next, you could document the activities we have and then also help with organizing our events. I hope I'm not too fast and you can hear and understand what I'm saying. Okay, and now we have a slide for joining our communities. By the way, the scan codes, they are working. In case this is all new, you can try and join in. We have LinkedIn, WhatsApp, Twitter, and Discord. And now to the main to the main topic of today. We'll be learning about Dockerizing Django app on GKE. Is it Google Kubernetes Engine? And our speaker will be Amdava. Please feel free, Amdava. The stage is yours. Just introduce and then you'll teach us. And with that, I'll now stop sharing my screen. Hi, hello, Amdava.
Hey, Elsie.
Hi. Welcome, Karibu.
Asante. Okay. Good evening, everyone. My name is Amdava. I'm a DevOps engineer at a company called Boopas. And yeah, today we're here to learn about GKE and building a Docker application to deploy for production. So just a disclaimer, it doesn't mean I'm an expert in this field. Probably there's someone in the meeting that is more well versed with what I'm going to present. It doesn't mean I know everything. I welcome anyone to challenge and to add feedback to whatever I'm going to share. But what you're going to deploy is an application for production use. So for production, I mean end users are interacting with this application, and it's supposed to be always be up. You'd expect it to be secure. You'd expect it to respond to traffic accordingly, making sure the application is more resilient and all that. So that's what you're going to talk about today. So I'll share my screen. I have a few slides. I'm not so good at doing slides, so just to guide me, and then we shall jump into a demo on how we can deploy this application to production. So I hope you're able to see my screen. Can't share your screen. Okay, try again. Maybe it's a permission issue, but I cannot be able to share my screen. Elsie?
Oh, you're not able to share a screen?
No.
So on this profile that you're speaking with?
Yes.
You should be able.
Okay. Is it showing now?
Not yet.
No, not yet.
Sorry, an error occurred while screen sharing. Yeah, cannot share the screen.
Oh, okay. So let me see. Let me see if I'll have an error on my end if I try to share.
Or maybe I could also assist if in case it doesn't work out. It's the slides, right?
Yeah, you could share the slide, but eventually you'll need also to share the code as I demonstrate. So either way.
Okay.
So I think it shares on my end. Let me try and make you a co-host.
Okay, just wait some. I think you added, I can be able to share with the other email.
Try now. Hello, Amdava.
Yeah.
Are you able to try?
Yeah. Sorry, an error card. Okay.
Okay.
Interesting.
Is it a Gmail email? Probably.
The first one was Gmail. This one is
Oh, okay.
my personal email.
Okay. So Elsie, if you have access, maybe you can share.
Okay. Oh, I'm only able to share the slides, but how
Yeah,
about
you
my
can do that
demo?
meanwhile. Then as we try to solve
Okay,
the other bit, yeah.
just a minute.
One actually.
The slides you're talking about are Amdava's slides.
Yeah.
Okay, okay, good.
Let me know once you're able to see at least a thumbs up.
Yeah, I can see it myself.
Awesome.
Yeah. Okay. Yeah, so that's about me, DevOps engineer at Bupas. So you could go to the next slide, Elsie. Yeah, so I'm going to break this talk into those 5 areas. So when we're talking about best practices when deploying an application to production in Google Kubernetes engine, we'll be touching on security, automation, observability, resilience, and cost. Yeah, so these 5 areas doesn't mean covers everything, but it will give you a 99% chance of your system being secure and scalable and resilient in the cloud. So we'll start with security. So in security, we are talking about a number of things. Google Cloud being a public cloud, you assign people roles, those IAM and access roles. So what roles do you give to these people, and what roles do you give to the service account that the users may have access to? There is a principle of least privilege in all the clouds, whereby you only give the necessary permissions required for a person or a service account to carry out their activities. So if you just need a developer to view pods or nodes in a Kubernetes cluster using IAM roles, you could just give them container cluster viewer or something like that. So by IAM and access, IAM, it means IAM and access management. So you give just roles that are just enough for a person to conduct the activities, so that to avoid accidental deletion, to avoid unnecessary activities on your production environment. And this, you have to understand, I'm talking about a production environment. Then we have role-based access control. Now, the difference between role-based access control and IAM and access management roles, role-based is within the cluster, within the Kubernetes cluster. Okay, so we have different roles or permissions like listing, deleting, editing, creating, deleting. So these are kind of the verbs in terms of the activities you can do within a cluster. So again, here you limit access to, you just give someone a role that they may require. And this most likely in production environments, the most people that interact with the environment are the DevOps engineer, maybe DevSecOps, maybe the CTO. But the developers and all, and maybe QA guys don't need access to the cloud. But if they need just access to view or to list or to see what's happening in production, you give them very least permissions that they need to do that. Another area where security comes in is in the secrets. And these we are talking about the API keys, the database connection strings that are sensitive and need not to appear in Git or in pipeline or wherever. They're supposed to be managed using secret manager solutions. Some of these can be within GCP. We have Google Secret Manager. We have open source like HashiCorp Vault. In AWS, I think it's called in Azure it's called Key Vault. In AWS, I don't remember the name, but we have different secret solution you can use. But of course, in this case, I'm I'm biasing towards GCP, so secret manager, or Kubernetes secrets. We also have Kubernetes secrets. Then for the cluster itself, by cluster here I mean the Google Kubernetes cluster. For production, it's always recommended for it to be private. By private, I mean you cannot do kubectl command against the API of that cluster. So you cannot list pods, you cannot list deployments from your local environment unless you allow your IP. So they're completely air gapped to allow to restrict access to the Kubernetes API. The same applies to the database. In our case, we are going to look at Cloud SQL database, where we created a private database. It doesn't have a public IP. Okay, for you to connect to it, you need to connect through what we call Cloud SQL proxy, which we shall discuss later on that. Then the DevSecOps guys will tell you you need to have up-to-date dependencies and everything, like on the requirement txt, you need to have up-to-date dependencies so that you rule out any vulnerabilities. So that's a bit about security. Automation. They say production environment should be hands-free. So you don't need to go and click to create, delete, update, and all that. So you need to create first your infrastructure with, it's recommended to create with infrastructure as code. In this case, you can use Terraform or Pulumi. In our case, we are going to use Terraform to create all the infrastructure. And this ranges from creating the virtual private cloud, the database, the users, and the cluster itself. So everything is defined as code and then build with that. Then CI/CD, in our case also, you're going to use Cloud Build. And by CI/CD, we mean continuous, you put in place a process where code is automatically updated, tested, security scans are done within the pipeline, and then it's deployed to GKE automatically. That is after approval has been done on Git or whichever way you want to set your approval processes. After that, you don't need to touch anything on production. Everything should be automated. And this is, I'm talking on an ideal production environment. Of course, most of us end up deleting, creating, and editing from the console. But regardless, we need to try. Then autoscaling, we are talking about your infrastructure being able to cater for difference in traffic. You may find some application, obviously, there are times when there are no much traffic, and there are times when there is quite a lot of traffic. In these situations, the infrastructure should be able to handle that traffic in a cost-effective way. Autoscaling here also comes hand in hand with cost, because now if there's no traffic, the infrastructure scales down and helps you save on some cost and all that. So autoscaling, in our case, we have a database that's scaling in terms of storage, and we also have a Kubernetes cluster that is able to scale the number of nodes and the number of pods depending on the traffic. So that's a bit about automation. Reliability. How reliable is your system? Every day I'm amazed by how some of the solutions here in Kenya are reliable. For example, calls, Safaricom calls, they're always on, whether there is power or no power, you can always make a call. Their data, I mean, Safaricom is one of the infrastructure that I am always amazed on how they're handling their infrastructure. They are very reliable. So how do you make your system that reliable? Okay, so in cloud we have the concept of zones, regions, availability zones. So most of our production environment, not most, all of our production environments should be deployed in a regional infrastructure. By region, I mean you have, for example, Europe West 1, which has about 3 or 4 zones, and each of these zones have their independent infrastructure in terms of power source, internet connections, and everything else. So if one zone goes down, it doesn't affect your infrastructure because your infrastructure runs across 2 or more availability zones. So your system becomes a highly available system. Okay. Then for backups, automated backups, that is, your system should be able to take backups, both of the application persistent volumes in case of GKE and all the application data, and also backups of the database. It's a good thing in GCP we have even backups for the cluster. I'll show you in the console in a minute, where you can be able to schedule your GKE cluster, and you can restore it at any time to a point in time. The same with the database. You can enable database backups, and in this case, actually the backups are, you can backup a database across multiple regions. So if at all, let's say Europe West 1 completely goes down, you can restore infrastructure in Europe West 2 or US East 1. Okay, so depending on where you've set your backups to go. This is particular for GCP Cloud SQL I'm talking about. Then the disaster recoveries. Of course, with the backups, you can be able to restore your application and DB to a point in time very fast because you already have everything backed up. Next is observability. This is like the single point of truth for any DevOps engineer. If someone comes and tells you the system is going down, or the system is down, or this application has these problems, the first place you check are your logs or your metrics. What's happening? Okay, they'll be able to give you a very good idea of what's happening. So for any DevOps solution, for any infrastructure you set up on cloud, it's always advisable you have a place where you can go and refer to see what's happening with their solution. So logging, you set up logging. You can either use cloud native logging solutions, like in GCP you have cloud logging, or you can set up open source ones like Loki, Grafana, and Prometheus to have more robust and custom-made dashboards. For monitoring, also GCP comes with one out of the box dashboards for metrics, which are very informative. And for me, I always don't like reinventing new wheels. If something already exists, then I make good use of it. So here we are going to look at logging, monitoring, and tracing solutions provided natively by GCP. And then next, LC. Yeah, the final bit is cost. I hope you guys had recently what was the cost for Twiga Cloud Cost. Does anyone remember? Okay. Lewis, yeah. So you can imagine that that is just the cost of cloud. I'm sure they are running some data solutions and all that, but nonetheless, cloud costs, there is always a challenge of balancing your cloud cost with reliability. Okay. Most of the people I've interacted with have said, I've never had a zone going down. It's very rare. So why should I have my application in a high available with 3 or 4 zones and they're costing much? And my CTO is on my neck that we should reduce cost. So there is always that discussion where if I set up a resilient infrastructure, yes, it will be resilient, but also it will have to cost. It will cost a lot of money to maintain the same infrastructure. So it's always good to have that conversation with whoever is in charge, so that you try to balance between reliability and cost. Okay, and these can be some of the things that can reduce cost. Obviously, is that auto scaling. You find machine types and images that are best suited for that particular function. If the application is compute intensive, then you look for compute intensive disks. If it's memory, then you do the memory. If it's both, then you find a way to get that disk, that's optimum solution for compute and memory. And then also it comes to small things like the application itself being built, you optimize the what we call the queries to make sure they're more optimal and they run fast. At the end of the day, you need to build a smaller Docker image that doesn't consume more compute and memory. In the long run, you end up saving on cost. Okay, so that's more bit about cost. So we'll be doing this demo as we point to each some of those agenda as we go. And I welcome questions to be asked whenever you feel like there's nothing you need clarity on. I have a repo I had created that has all of these code that you can try to work on and maybe improve and all that. Now this screen sharing bit is the one that's tricky. Let me try again. Yeah. How are we going to do this now? That's refusing us to share. Let me look at my permissions. Bear up with me just a minute. I'm checking the permissions. Maybe I disabled them. So meanwhile, you can ask questions if you have any questions as I try to solve this.
Any questions from anyone? You can raise your hand if you want to ask a question. Is sharing the screen the issue?
Yeah, I'm sharing again.
Oh, okay. So else you can stop probably. Yeah.
Yeah, it's okay. I have.
It's now showing, right? Excellent.
Yes.
Yeah, I had disabled it from my local. Okay. Now minimize you, minimize. Okay. So you can see my VS Code, eh?
Maybe you can zoom in.
Okay. Better.
One more time. And that's better.
Do you guys like white light theme or dark theme? Don't crucify me. There. Is that better? So this is my repo. I also have it on GitHub. I'll share the link. You can add a few things. You can remove. You can comment, and we can be working on that. It's also a way I'm trying to document this year. So for guys who are asking how I can document my projects, maybe you can do this, and then it will be, you'll have your portfolio of things that you've been working on. There's the link. So it's public, you can clone, and then we can work with that. So the report, we have the Django application. We have the K8 folder. These just apply the manifest, and then we have the Terraform folder that's used to create the infrastructure. So I'll just go quickly on the Terraform. Terraform folder, you can arrange it the way you want. I always go with the simplest arrangement. So we have a VPC, and VPC is virtual private cloud, which is custom. So we are deploying our application in a custom VPC. There is always a default VPC in every region, but we choose not to go with that. We create our own custom VPC. And you can see here it's global, so it's across the globe. Then we have one subnet, which is web. Now this is for the cluster, the GKE cluster, and we have another, and this for the cluster we have different ranges, IP ranges, secondary IP ranges. We don't need to go into that, but just to note, we have for the pods and the services. And then we have another subnet, that's data. This now for the database. The reason why I've put them differently is because we are applying different firewall rules to them. And firewall rules simply means you're restricting which traffic is allowed from which host to which host. So we also have an IP address that we shall use for load balancing. Then we have a router, cloud NAT, and these are the firewall rules. So cloud NAT allows access from internet to a private subnet. So that cloud NAT, we are attaching it to the web of obviously subnet, the one that we shall be using to access application from Kubernetes. And finally, we have compute firewalls. This is 36. This is the port for Cloud SQL. You could choose to use a different port, and it's only allowing traffic from this subnet, from this address, which is the one for subnet for GKE. So it only allows connection from GKE to make it more secure. So that's the firewall. And then lastly, we have compute firewall for the cluster that allows you can allow authorized sources, for example, your IP, to connect to the cluster. So that's all about the VPC. Then we have the SQL cloud for creating the Cloud SQL cluster instance. Sorry, I'm creating a random password for the cluster using the random password provider of Terraform. And then I'm creating the cluster. Now the instance here, it's MySQL version 8. It's regional. I prefer it, the one of the region to be zone A. This is the DB tier, which means the disk. It's only 10 GB. This one can auto increase. So in case you need more size, then it will be able to automatically increase its size. Then IP configuration, we are only we are building a private cluster, so it's only a private IP that will be allocated to this instance. We shall see in the console. I've also scheduled backups every day from 6 a.m. And then this is just a database. This is a user. This is an IP address to use for the internal IP address. And this is the private connection for the database. Then we have GKE. This is the cluster now. It's a private cluster. So things to note here is we have master authorized network config. You can only allow a certain IP address to access this cluster. So these ones, you'll define it in this variable called authorized source ranges. And then enable autopilot, true. So one thing to know, when we talk about cost, I told you about auto scaling and scaling. GCP recommends you to run autopilot cluster. We have two versions of GKE clusters. We have the autopilot one and the standard one. The standard one is the one that you have a control plane and then you provision node groups. You can provision as many node groups as possible. And then the other one that's being recommended these days, it's called autopilot. So you don't provision any node group. Your cluster will always scale up depending on your needs, and you can specify the limits to scaling. So that's GKE. So those are the three things you could that are of importance. This is just the main file with the provider and the backend. Then we have this is the YAML file to deploy the application. In ideal world, we should use Helm, but I felt that Helm is more kind of advanced. I didn't know that my audience, so I'd recommend to go with something that most of us are familiar with. So we have a deployment file to deploy the application. And one thing to note is I have two containers here in this deployment. I have this called Pulse, and I have this called Cloud SQL Proxy. Okay, so what is happening is now that you are connecting to the Cloud SQL via Cloud SQL Proxy, we are running this proxy application, this Cloud SQL Proxy, as a sidecar to the main application. We are using the sidecar pattern, which means communication between this Pulse application and the sidecar application will be through localhost, via localhost. I don't know the best way to explain that, but what I'm saying is you give Cloud SQL access to the database, and that Cloud SQL proxy is running inside the container of the Pulse. So definitely the Pulse application will be able to communicate to Cloud SQL via the proxy. So that's the deployment. And we are mounting a few secrets like the Cloud SQL and then the service account for workload identity. This is the service YAML to deploy the service. Then we have, actually, we are not using managed certificate, but we have ingress where we've defined how to access the application. And we are going to use Nginx ingress controller and cert manager cluster issuer to provision certificate for the application. Then this is the simple Django application. I just got it from one of the Google Cloud sites. It's called Pulse application. And few things to note in this folder. We have Docker file that's used to build the application. Remember, GKE only runs Docker images. So we are Dockerizing that application using this Docker file, 3.10 Slim. Then I'm installing the build dependencies, then the requirements.txt. And then I'm running that image with an app user. I'm not running it as a root user. For security reasons, because if someone gets access into that container with root access, they can be able to manipulate. And so it's a security feature to run your application, and always recommended to run it with a non-user user. And then I'm using Gunicorn obviously to run the processes. Then I have Cloud Build YAML that's now being used for CI/CD. So it has three. It has 1, 2, 3, 4 steps that we are defining. We have the build, and this simply builds the Docker image using the Docker file. So Docker build -t to tag, and then I'm using artifact registry name. For example, it's not Docker. I'm not pushing to Docker Hub. I'm using artifact registry. I'll show it on the console. And then this is the naming convention of images in GCP. You have to start with the registry name, the project, the name of the repository, and then the name of the application. And I'm using the commit share as the tag. Okay, so that's build. Then we have the one to push to container registry. Then these two steps are not implemented today, but these two steps as for running migrations. If you have migrations, depending on how developers in your company works or wherever you work. For example, in ours, they make migrations and push the migration files. Then what I only do is to migrate. This is for the case of Docker, of Python, of Django, that is. Then my case is just to migrate. In some other environments, you need to make migration and then migrate. Either way, you can define those as steps in a cloud build. You can also add application tests end-to-end tests. You can also add this the security scans if you are using, for example, what is the name? What's the most common? This one you can install on-prem too. Security guys. There's this so something. I just forgot it. You can run security scans also as steps within Cloud Build. And then the final one is to deploy now to the Kubernetes. And one thing to note is Kubernetes is a private cluster, as I said. You need to add your IP before you can run kubectl commands. So that's this command here, the dig command, is used to get the current IP of the worker nodes that I'm running on, where this Cloud Build, after all, Cloud Build is running within a server. So this command gets the server IP. This one updates the cluster with that IP. And then this one gets connection to that IP. G-Cloud Container Cluster get credentials. So it gets credential and save it in the /.kube file. And then finally, we are updating this Paul. We are updating the deployment using set image command. So whichever image you've built here, this one that has been tagged here is the one now that you will update here. So we're updating that image so that the latest code is deployed. So that's the Cloud Build. If you have questions on that, we can discuss more. And then this is just a simple app. It doesn't have anything in it. We only have, it has admin, of course, page. Then it just posts, hello world, you are set to run Pulse Index. Okay, so that's the application. Now, go to cloud. So this Google Cloud, this is how Google Cloud looks like. And we are using first Cloud Build to build the images. We're also deploying to Kubernetes engine, and you're using Cloud SQL. What else? You're using VPC. Just a high level overview of this different infrastructure. So I already ran Terraform. This one takes around 15 to 20 minutes to create. So I just ran them earlier on, of course, as I tested. I didn't want everything to fail now while doing the test. So this is the production MySQL that was built. Things to note. It's version 8, obviously MySQL. Auto storage increase is enabled, which means storage increase can be done automatically. You don't need to worry about that. Automated backups are enabled. So I'll show you the backups. Point-in-time recovery, which means if a database goes down now or your database gets corrupted now at 2045 and you want to restore it to 2040, you can restore it to 2040 if this feature is enabled, point-in-time recovery. Okay, then instant deployment, instant deletion protection is disabled. The reason why I disabled this is if you want to destroy this cluster with Terraform that you used to create it, it will not destroy. And now you'll end up going to the Terraform state to edit that. Maybe someone has a better way of doing that, but in my case, mostly I disable this deletion. Then eventually I come and enable it from the console. Then it's located in the US Central One. It's highly available, which means it's regional. Okay, so those are some of the features of production database. If you come to backups, you can see we have a number of backups already. And the backups are multi-regional US, which means you can restore it to any region within US. That's what backups multi-regional means, okay? And then connections. When you come to connections, you can see here they're saying public IP connectivity is disabled. Service connection method, private access, services access. So this database does not have a public IP, if you can see here. It only has private IP, and it's within this VPC, prod VPC. But if you want to connect it from your local, then you can enable this, and then you add your IP here. you add your, you name it and you add your IP here, then you done, then save, then you can be able to run MySQL commands from your local host to this database. But as it stands, it doesn't have public access. That's the SQL. We have this is the Kubernetes page when you come to GKE. So I told you there are two flavors you can create in GKE. But when you say create, automatically you see it starts an autopilot cluster, but you have an option to switch to standard cluster. Now, autopilot cluster, you only need to specify very few things: the name, the region. If you want to record to put it into a fleet of different clusters, you can register here so that you can use other function like for managing multiple clusters. Then the networking, you define the whichever network you want it to be. A non-default. It's always recommended to have a non-default. So in my case, it's prod VPC. It has 3 subnets. This web for the GKE. This one I just created for tests. Then we have data for the database. But you can have as many subnets as you want. Then here you can say it's private or public. For production, it's always advisable to run a private cluster. And then you enable control plane authorized network if you want to run commands from your local host to connect to the cluster. This is where you enable it and you add your IP here. Okay, but in ideal situation, in ideal production environment, run a private cluster. But this one you can do it even if the cluster is already created. You can go in and edit. It's just a few seconds and you'll have access. Then we have advanced more. You can create automated maintenance window. You can add it to service mesh. You can enable binary authorization. So these are advanced security features that you'd want to run them. And finally, now you can review and create your cluster. So that is autopilot cluster. As you can see, there's nowhere they're asking us to describe the node pools and all that. But if you switch to standard, you can see now standards. One thing to note, autopilot cluster, it's always a regional cluster, okay? Because it's highly available by default. So you don't need to specify if it's zonal or regional. So this is a standard GKE that you'd normally provision. You'd register it to a fleet if you want. Then you need to define the node pool the way you want. You need to manually decide the auto scaling and everything. But this is not the case for us. So, but if you want to interact with how the differences are, then you could always come to this dashboard and try to create the two and see the differences in creating them. So this is our cluster now. Just to go through it, it's regional, of course. The high availability, it spans through 1, 2, 3, 4 zones. So obviously, if even these 2 zones go down, your application, chances are of it being still up are high. Then I decided to run on 1.27. I think we have 1.28 now, Kubernetes. So you can upgrade if you want. Automation, we have automated backups. Networking, it's a private cluster enabled. Control plane, this is just networking stuff. Control plane global access disabled. By this, it means your cluster can be enabled, accessed from any region, even on-prem through Kubernetes API. Then this is the network, the subnet. One thing that you needed to see, where is it? Workload identity is enabled. So workload identity is simply, it's a security feature where we are giving the application mimics the service accounts that you've created. So you create a service account, you give it a certain permissions, then the application is able to use that service account to carry out its activities. So this is a Kubernetes cluster, private autopilot Kubernetes cluster, the mode autopilot. there's no number of nodes, because by default it doesn't run on nodes. It will just spin CPUs and memories, and billing on this is based on the number of pods that are deployed, not the number of nodes, as it's the case for the standard cluster. If you come to workloads are now our applications that you've deployed. And we have quite a few namespaces to look at: Sat Manager, Ingress Nginx. Okay, so as I said, we are using Sat Manager. For those who know what Sat Manager is, to create SSL certificates for HTTPS connections, Sat Manager. That's what's been deployed here in the Sat Manager namespace. Then we have Ingress Nginx controller here. So this is the one that's this one creates a static IP to be used for traffic routing across the cluster. So this whole cluster will have a single IP address that we can use it to map DNS records for all applications running in the cluster. And where do you see that IP? That IP is in the services. I hope you guys understand the different Kubernetes objects that I'm talking about, just by the show of hands. Can you name like 3 Kubernetes objects that we interact with? Just list them. Yeah, Moses. Moses, you've raised your hand.
And if it's the permission issues to me fix, you can also type in the chat box.
Yeah.
Okay.
Or I'll start pointing fingers.
Moses should be able to talk. Only you have not unmuted yourself, Moses.
Okay, as we wait. Yeah, Lewis, correct. Pods, namespaces. Okay, we shall go with those. So we have quite a number of these.
Sorry, I was.
Okay, Moses.
Sorry, technical challenge.
Moses, are you tending to the animals? I know you're also a farmer.
Challenges. Anyway.
Okay.
I've seen someone has already mentioned a few.
Yeah, they have Moses.
We have config
you really
maps,
have
volumes. I don't know if you mentioned we have pods like you. Not right now.
Wow, now it's when he's getting the job of.
So we have config maps. We have
Moses. We'll have to get back to you. Please try and get a better connection. Then we can continue. So yeah, as I was saying, we have a number of Kubernetes objects that you're using. We have deployments. That's what creates these deployments, the workloads. We have services. Services, this one is the one that now allows communication between deployments. And then finally, we have Ingress that exposes our application to the internet via HTTPS connection. That's secure connection. For example, that you see this connection is secure. Then we have certificates from Let's Encrypt. So a valid certificate to make sure that this application is being reached out from the internet securely. So yeah, so we have these applications being deployed here, but how did we get here? How did we get to it being showing this page here in a secure using HTTPS? Okay, we're using Cloud Build for automatic builds, and one of the things you could check out is the trigger that's I can explain. This is a trigger that now watches, I could say watch or looks out for changes in Git. Okay, so I have this project called DevOps project, the main branch. Okay, so if there is a push to this branch, then it will trigger this pipeline to use this cloud build file that I explained to run and deploy the application. You can also send these logs to GitHub. It's very important because most developers will not give them access to the cloud, but the logs, build logs and deployment logs can be viewed on GitHub. And that your developers can see if it failed or passed and why did it fail or why did it pass. You can also specify a number of responses to which this trigger can be triggered. If it's a new tag, you only want it to run if there's a new tag, you do it here. If it's only run during pull request, you do pull request. But in my case, I decided for any push, then it will build. Now, for production also, we also recommend approvals. In this case, maybe before anything is introduced to production, you can have a security gate just to require approval before the build goes into live, because now you don't want to introduce bugs and if everything's not yet tested. So that's the trigger. And then we have the repositories. You can add as many repositories from here. So this is Cloud Build, and this is the one that caters for CI/CD, both CI and CD. Some people choose to use cloud agnostic tools for this: Jenkins, GitHub Actions, Travis CI, all those other things. But in our case, we are doing Cloud Build. And as I explained, Cloud Build, you can have as many steps as you want. These are how steps look in Cloud Builds if something passes. As you can see, there are so many failures also. Just reiterating what Elsie said at the beginning, ni kujituma. It fails, you test again. It fails, you test again until it passes. Okay, so these are the like 3 steps: Docker build, Docker push, and deploy to Kubernetes, and all of them have their respective logs. Okay, so if in case it fails, you'll know why did this build fail. For example, this one passed, this one passed, this one passed. Then migrate database, it failed with this. But the Django people in the house, if someone could help me solve this, I'll be really happy. I've not done it before. Solved it, but of course I'll solve it eventually. But if you've come across it, could be very helpful, especially when this thingy host, you specify the variable for host and it throws this stupid error. Really disturbing. So this one failed because of that. Okay. This is Cloud Build, how it looks, just an overview. Remember, you can always sign up for GCP trial account and you can practice all these things and document and build your portfolio on GitHub. And then the recruiter from Google comes and say, yes, I have projects, man. I'm experienced. Give me the job. And you get a job. Okay. So that's Cloud Build. This is Kubernetes engine. Now we go to the application now. Django. So what are the things you do, you edit for your application for it to run in production securely? Now, the first thing, we start with the settings.py. This one here, this guy here. There are a few things you can edit. For example, debug. Debug in production should always be false or true. Genuine. Sorry, I've got so many things. False, 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 false. Yes, correct. So debug should always be false. So for me here, obviously, I've said if I want to override it, then in .env, I'll put true, and then it will always take the true one. But kama hakuna, then chapa false up. Then allowed hosts. If you want to restrict any just to the host that you want, for example, in my case, it's pulse.amdava.org, then I could just in the environmental variable specify it here. Then another thing is also for the database, you always get all your strings from the variables. You don't hard code stuff. You don't hard code anything here. Then for my case also and Django, I'm serving my static files from cloud storage. Normally you could use white, is it called white noise or something, to run your static files within the application. But in my case, I'm serving them from GCP cloud storage bucket. And that's bucket, I name it with this variable. Then we have these SDK for connecting to the cloud storage, and it's public read. Obviously, those static files need to be public for it to render on the site. So that is some of the at least most of the changes that you do on a Django application to make it more secure, so that you don't add code values, and you also serve your static files from an S3 environment, like it can be cloud storage, it can be AWS S3 buckets, it can be Azure cloud storage buckets. Okay, so that's the changes that I've made there. And then what else? Of course, for running locally, I have my .env file. I added the cloud build to define the steps to build. I added the Docker file for, obviously, to build the Docker image. And then finally, what I did just commit it. Obviously, I ran migrations. We have the migrations here. So let's say, I think this is here. Hello, DevOps Nairobi. So we've introduced a change. Okay. Then you do git add commit. Just join commit message gani, but nonetheless git status. I remember talking about importance of Git in DevOps. It comes down to even the commit messages and all that. Obviously, I'm work in progress, like many of us. But it's always good to have a very clear Git commit message, so that whoever is reading that should be able to understand what's happening. Okay, why is this showing there are no changes? Git details. Nothing to commit, man. Okay. I want to commit something so that when we change, come on. Wait, man. Okay. Let's see. Okay. Let me make changes to that. Let's remove the root user first and see. They always say never demonstrate on what?
Are you in the same? Are you committing from on the same directory on your terminal?
Yes. CD, actually no, Django. GKE. Hapo sawa. Some status ala Django. Yes. Guitar status. Yeah. Story of my life. Even cloud build, Docker. Okay, this is the root git status. Now let's change something on.
I can see on your terminal you're inside Django projects, but here you're inside, on your VS Code, you are inside Django GKE.
So the parent, this is the repo. Then it has the Django GKE as one of the projects. Okay, so ideally, if I created this Django GKE after I created the repo, so and I've made changes inside here. So either way, it should show Django GKE, and we have now the Django app itself that I've made changes, but still. Yeah, this is the home directory. So that's okay. The service, we were to remove the managed certificate. Okay, that's a very serious change. No, it's not even there. This is wrong. Yeah, interesting. What's happening?
Try opening the terminal on VS Code, and we use that terminal.
Okay, so here, the roots. Check. Develop. Returned. Before I push that, let me just change this. Trigger. To change the branch to develop. Okay. 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 I'll find out why that problem is. Now we push to develop branch and a build automatically triggers. And these are the steps that will deploy the new application. Hopefully it will deploy with this message that we had changed here. Here. Because currently, I was to show you the case. ingress. Even this is the wrong ingress, man. What's wrong with this Git thingy? Kubernetes. Ingress. So currently, if you open this, what it shows, hello world. Okay. So we are hoping when it builds, it will change this just to demonstrate that it's building and deploying the latest image. So yeah, I think up to there, that's more or less what I do when deploying Django applications to productions in GKE. What I didn't mention or didn't touch on is use of Helm charts for production and GitOps, which I feel needs more explanation on the whole concept of GitOps, building and pushing with Argo CD, and then using Helm charts and sub charts to deploy your applications to GKE. So Helm is just a simpler way to deploy applications for those who are not familiar with it. They call it package manager for Kubernetes. So, and to run Helm is as simple as, let me just, I'm talking as we wait for it to deploy. Okay, I can create a chart, Helm create Django. So you create a Django, then cd Django, I want to see, then code. So this is how a Helm chart looks like, typically. We have the chart.yml that defines the name of the chart. So if you deploy to Kubernetes, most of your application will have the Django name. Then we have the templates here, and you can see the different Kubernetes resources, objects defined here. We have the deployment file. So it's the same as the other deployment file, but now in this simple Helm language. Then we have the horizontal pod autoscaler, we have the ingress, we have the service, you have the service account. Then if you have custom values, that's where you put it here. For example, the name of your image and the tag. If the image is in a private repository, you need to have image pool secrets. You need to create service account. If not, you put it false. You define the security capabilities here. If you want the service to be load balancer, you put load balancer here. If it's a node application, for example, ports can be 3000. Then you enable ingress, you put it to true, the different annotations to use. If you're using Nginx class name or you're using GCE, or you're using Traffic, or you're using any other ingress class name, you specify here. Then the hosts, this is the URL, the domain name that you'll connect to your application, you'd specify here. The resources, if you don't want, if you want to limit your pod to use certain number of resources, you specify here. And of course, also scaling, and if it has volumes and everything. So you specify everything within the values.yml file. If you have different applications that share most of these things, you could just add another YAML file here, for example. You can also have even dev values.yaml, and you give it different values. Okay, so you can have as many values as possible. Okay, so you can have as many values as possible. And just to show you just a glimpse of how Argo CD works, I can do dev.cd. This one I run for my dev. So this is Argo CD, responsible for now continuous delivery. Okay, and you can see I have quite a number of applications running, and all of these have been deployed with Helm. Okay, so it's kind of, I felt if we delve into this, it will take longer, but if time allows another time, we could talk about Argo CD in detail. So coming back to our build, so this is the latest build. Let's see the changes that we introduced first. That was documentation. Okay. This is very strange. To pilot cluster. On Terraform, there is no change on the folder. Why? The Django GKE, Django Pulse, views. So this one did not change. Very interesting. Let's do what it's always not allowed, not recommended. This is main branch, sorry. Let's see, develop. And also another thing on Git, there is always a way you could restrict people from committing directly to main branch. So you lock it, okay? That's also another thing you could implement wherever you are to make sure that guys don't just push to main branch. That thing of showing the build logs from Git, it's here. So you can always see how the build worked. So you can see the logs from here. Yeah, so you'll see the logs are here. From Git, that is. You don't need to have access to GCP to see that. Okay, so let's introduce that change that we said in develop. But ideally, you guys can see that the pipeline runs and does that. So it's just this funny thing that happened. I am done. Questions?
Anyone with a question? Well, okay, we have Hillary. I think I saw someone lift their hand.
So hi, can you guys hear me?
Yes.
Yes.
So my question is specifically on the CI's part. Do you have maybe the scripts for test before the app is deployed? Maybe when a dev makes a new change or something of the sort.
So at the moment, I didn't write any scripts. In an ideal world, we should have QA people doing those scripts, and they tell you run this command to test the application. But I don't have the test scripts to integrate into the pipeline. Maybe we could work on creating that, and then because this repo is being updated every now and then, it will be updated by me. Actually, I'll be working on them with among other projects. So maybe I can have a Django developer to create the test scripts, or a QA person to have the test script to run the tests in CI.
I hope you've been answered, Hillary.
Yes, I'll be following.
Awesome. Hadi mi niko na swali. So in short, let's say you have an app, whatever app you have, if it's in Django, and then you create an image, alafu unaeka hizo ma services na hizo ma sat manager, then you deploy. Like those are the
Yeah, so once the application has been built and it's ready for tests or for deployment, some developers create Docker files. Some don't. They tell you the repo is ready. So you go in, you first run the application locally to make sure it's running. They are not just telling you stories of Java. Then when it's running locally, then you build the Docker, you create the Docker file. You also run that Docker file and confirm that the Docker being built from that file is also runnable. Okay, then from there now, you create this cloud build file, the CI/CD file. Remember, I'm talking specifically for the case of GCP. Okay, CI/CD can be different tools you're using. You can use Jenkins. In that case, you'll need a Jenkins file, Travis CI, Bitbucket pipelines, GitHub Actions. So you have different ways you could build your images in CI. So whichever one you decide, you need a Docker file. But these other files, like the cloud build files, is dependent on your CI. Then yeah, you build that file, then you add it on the repo and you define your trigger. Now, how will it respond, and it will respond to what? And then it will build the image, push it to artifact registry. For GCP, we call it artifact registry. It's like Docker file, Docker Hub, but for GCP. Okay. So you can also choose again Docker Hub. You can also choose AWS ECR or Azure, the one for Azure. Depends on which one you want. But at the end of the day, the ideal is build Docker images, push it to a container registry, and then deploy it to your infrastructure, to your hosting service. For my case, or for our case, is Google Kubernetes Engine. You could deploy it to a virtual machine compute engine. You could deploy it to Cloud Run. You could deploy it to App Engine. You could deploy it to Azure Kubernetes Engine, Elastic Kubernetes Engine for AWS, whichever platform. But ideally, the process is still the same: build, test, push, deploy.
Okay. Thank you. Anyone with any other question? Yes, Pravik. And then
Kiprono Ian.
Yes, first let me say thank you for the wonderful presentation you've made. I've really learned a lot from what you've shared with us. Then my question would be, at what point do you advise to shift away from the platform-specific Kubernetes, like for instance, the GKE or EKS for AWS, and use the independent Kubernetes?
Okay, interesting. First, I would advise, okay, my personal take, I'd never want to go for self-managed Kubernetes. Let's say I build my own Kubernetes from scratch and deploy my production environment there. That will be quite a lot of work. But yeah, people choose to go to, let's say, we could call them on-prem, or we could just say personalized Kubernetes environment for either they want a very airtight environment, very secure environment. By that you control everything in terms of setting up the cluster, the networking, and everything. That would be one of the reasons why you'd want to have an on-prem or that kind of setup. But ideally, I would think cloud would be the best. And the good thing about Kubernetes, and especially if you're using the GitOps way of working with things, and all of your tools are cloud agnostic. By that I mean you're not dependent on any particular cloud to run your infrastructure. Then migrating from one managed Kubernetes, for example, from GCP to GKE to AKS or to EKS, it's more simpler if you're using GitOps, because you just need to back up your setup and you restore to the new cluster. But you are asking, why would one consider moving to non-cloud Kubernetes? I would say maybe for security reasons, or that person just loves adventure and loves stress managing the cluster. That would what I'd say. Okay, Ian.
Any other last question? Nilikuwa nimeona mkono ya Provic, I think. Well, time is up. Oh, first of all, thank you so much, Amdava, for taking the time. It's been a detailed explanation, and time is up. So, if we don't have any other questions, we've come to the end of our session. I'm really grateful for each and every one of you for being here. Swali yangu, I won't ask today, next time, because saa imeisha, yeah? So have a productive week ahead, and watu mjitume. Thank you, and good night.
Thank you, Elsie. Have a good night too. Bye bye, everyone. Okay, Ian, we can sync on the migration issue.